Hey class, so let's talk about actually answering one of these questions where there's a force applied on an object that's on an inclined plane. So very standard scenario in the sense of when, and I was actually doing this yesterday, pulling an actual child or pulling someone on a sled up a hill. So we have sled, mass, someone pulling up a hill. So let's actually go through this question in the sense that it gives a force applied, and in the end it's going to ask basically what is the acceleration of this scenario. All right, so with mass of 40 kilograms, we have a coefficient of friction of 0.30. This is the exact same question as the top one on the worksheet for this week. So I'm going to go through this one. The second video I'm going to go through is not going to be exactly the same as the bottom, but it is going to be similar. Okay, but let's go through first question on the back side there. So we have to find, again, we have to find that force normal, and then force of friction and force parallel. So let's go through that. Let's find force of gravity first. Should be our easiest one. Force of gravity equals, again, just mass times 9.8. So I get 392 newtons. 392 newtons. Put kilograms here. All right, next thing, I want to find force normal. So I found this. I found force of gravity. I want to find force normal, which is, again, just this. We're breaking this force of gravity into the dotted line to get force normal. So that is going to be, and I have our little formulas over here for this week for our inclined planes. Find force normal, we're going to be finding this adjacent side. So we're going to go cos theta times force of gravity. So we're going to be going cos of 30 degrees and then times it by 392. When I do that, I get an answer of 339.5. 339.5. So that is my force normal. 339.5. All right. With that, I can find my force of friction. All right, I'm a little off screen there, sorry. With that, I can find my force of friction. Now, the most important thing to remember this week is I can't put a direction on force of friction yet because I don't know which way this is moving yet. I don't know if force applied is winning, if force parallel is winning, so I can't really put an arrow to force of friction yet. I'm going to find it, but I can't put an arrow yet. Force of friction. Okay, same as, it's still mu times force normal, so I have mu, 0.3 times what we just found, 339.5. And that gives me an answer of, I think, 101, there, 101.9. I'm not going to put an arrow yet. Last thing I find is force parallel. Sorry, I'm cutting out the screen, but last thing we're going to find is force parallel. Force parallel is going to be over here, how we find force parallel, which is this right here. I'll put a different kind of color here. Force parallel is this. When we break up that force gravity, because we're at an angle on an inclined plane, that's what we're trying to find. So it ends up being this. Force parallel. How we find this right here is that's the opposite side. So we're going to go sine. Sine theta times our gravity. So sine of 30 degrees times force of gravity, back up here, 392. All right, when I do that, I get an answer of, I think 196. 196. I can put that actual arrow in, because that is going down the hill. 196. Okay. So let's look at this problem as it stands right now. I still haven't added in one of the forces. I haven't added friction. I'm going to do that right away. Let's look at this problem. We have, let's call this me, pulling up at 385 newtons. Force parallel, basically gravity pulling me down the hill. Who's winning? Well, the nice thing is I'm winning right now by quite a bit, almost 200 newtons. Not quite, but almost 200 newtons. So because this is going to be wanting to move up, friction is going to be going the opposite direction. So let's now actually add in friction. We'll put a blue arrow in here. Force of friction, which we found, is 101.9. So now we can find my net force. My net force is going to include three. Force applied, force parallel, force of friction. So let's go through that. All right. My net force. Net force is going to equal, okay, I'm going to take whatever's winning, the side that's winning first, and then I'm going to minus my other two actual forces from it. And you're going to do that on any question. If force parallel is winning, if force of friction was going the other direction, you use your force parallel for it, you'd find your biggest number, between force parallel and force applied, and that's the number you start with. So I'm winning. I'm going to use my number first. 385. 385 minus 196. That's force parallel. Minus 101.9. That's friction. When I minus this from those two, I get still positive answer, 87.1. 87.1, which means that I am beating both of these forces. So this thing will be moving up the actual ramp. So force applied, Mr. Westwood, is beating force parallel and force friction. This thing is going to be moving up the ramp. That is our net force, 87.1 newtons. Last simplifying acceleration, you take that net force and just divide it by our mass, which 40 kilograms. All right, 40. And so we had 2 point something. Let me look at my actual sheet here. I think it's 2.199 something. We're going to go 2.2 meters per second squared. And that is how fast Mr. Weston is pulling up this water sled, whatever this object is, up a ramp, up a hill, something like that. But that would be how you find this question. Okay? So there's one scenario, and since force applied is winning, I'll do one more question where we might have a different scenario, and we'll go through it that way. All right, thanks, class.